Imagine a tireless industrial pump sitting in the middle of a city-sized factory. No holidays, no night shift, no complaints. That pump is the human heart. The factory is the body. Every department, brain, liver, kidneys, skin, needs raw material and waste removal. The heart is the central hydraulic engine that makes logistics possible. The story begins at the right atrium, which works like a low-pressure receiving tank. Used fluid returns here through two huge pipelines, the superior and inferior vena cava. This fluid is dark, oxygen-poor, carbon dioxide, rich. In machine terms, it's coolant that has absorbed heat and waste from the system. The tank fills, sensors stretch the wall, and the first actuator fires. The atrium contracts gently, pushing the fluid through a one-way flap valve, the tricuspid valve, into the right ventricle. Valves here behave like precision-engineered check valves, flow forward only. Zero backwash allowed. The right ventricle is a medium-pressure pump. It doesn't need brute force because it's sending fluid only to the lungs, a nearby processing plant. When the ventricle contracts, the pulmonary valve snaps open and the blood is shot into the pulmonary artery. Notice the elegance. Arteries are defined not by oxygen content, but by direction of flow, away from the pump. In the lungs, the blood enters a vast microscopic filter system. Think of millions of parallel gas exchange membranes like an industrial scrubber. Carbon dioxide is dumped. Oxygen is loaded. The fluid changes color, chemistry, and energy potential. Freshly reconditioned blood returns through the pulmonary veins into the left atrium, another receiving chamber. This tank handles premium, oxygen-rich fluid, so the next pump must be stronger. Through the mitral valve, a beautifully tensioned valve held by chordae tendineae like suspension cables, the blood enters the left ventricle. This is the main engine. Thick walls, high torque. This chamber generates the pressure needed to push fluid through thousands of kilometers of piping. When it contracts, the aortic valve opens and blood explodes into the aorta. From here, it's distributed through branching pipelines, large arteries, smaller arterioles, and finally capillaries so narrow that red cells must fold themselves to pass. This ensures slow flow and maximum exchange at the work sites. After delivering oxygen and nutrients and picking up waste, the fluid returns through veins, pressure gradually dropping until it reaches the right atrium again. Cycle complete. This machine runs about 100,000 cycles per day, moving 7,000,8,000 liters of fluid, powered by electrical signals generated by an internal control unit, the sinoatrial node, the natural PLC, programmable logic controller. Backup wiring exists. Redundancy is built in. Failure tolerance is remarkable but not infinite. Unlike factory pumps, this one repairs itself, adapts its output to demand, speeds up during stress, slows during rest, and responds to chemical signals from the entire system. A self-maintaining, self-regulating biomechanical engine, older than steam engines, more reliable than turbines, and still unbeaten by anything humans have built. That's the heart. Not poetic, not symbolic, just the most efficient living machine ever put into continuous service.